Hey YouTube, thanks for visiting. So in this session we are going to discuss the isoperimetric problem for calculus of variation. Okay, isoperimetric problem. Okay, so in the previous lecture of calculus of variation we discussed the general things. We just introduced the calculus of variation and see the Euler-Lagrange equation. Okay, and the different cases and sub cases of Euler-Lagrange equation and different ways, so that the dependent number of dependent variable, here are derivative terms included in the extreme, is included in the functional. Then we see the different Euler-Lagrange equation, different form of Euler-Lagrange equation. Okay, and in this session we are going to discuss a small thing which is isoperimetric problem, which is one types of calculus of variation problem. Okay, so let's start. I think these are already taken. So this is the isoperimetric problem. Okay, so what is the isoperimetric problem? So see, suppose that, and one more thing is that those who are new in my channel, and if the content is helpful for you for your exam preparation, then obviously give a like to this session or like to this lecture, and those who are new, please subscribe the channel. Okay, so let's start. So suppose, and I also link the previous video of the calculus of variation in this iTab and also in the description. Okay, suppose we have to extremize the functional, and one more thing is that I already discuss 100 near about 100 questions of PD. Okay, for CSR net practice session. So you can also see for your practice of partial differential equation, and also you can check the videos as a mock test, and also OD, some OD problems is also available in the different two playlist. Okay, and in the playlist of 100 plus question practice on PD, you will get the approximately 100 questions of PD for your practicing. Okay, and also you will get the OD question in a separate playlist. You can also check that. I also provide the link of those playlists in the description. Okay, so see, suppose we have extremized the functional I equal to integration x0 to x1 f of x y y dash with the condition y x0 equal to y0 and y x1 equal to y1, subject to the constraint x0 to x1 g x y y dash is equal to 0. So this is the functional, and here one constant is added in this case. Okay, so in the previous lecture we already discussed up to this thing. Okay, and here in this isoperimetric problem the case is that another constraint, or you can say one more constant is added to this problem. So this type of problem is called the isoperimetric problem for calculus of variation. Okay, now we see working rule for this isoperimetric problem, or how can we solve this type of problem, that is the isoperimetric problem. Okay, here we construct another functional h is equal to a plus lambda g. This lambda is called the Lagrange's multiplier, and also in this case this is also can be written as in terms of L, or this a plus lambda g is also denoted by L, and L is says the Lagrangian. Okay, some books use the term Lagrangian for this h or L. Okay, so lambda is called the Lagrange's multiplier, and this h is also satisfy the Euler-Lagrange equation or Euler's equation, that is del h del y minus ddx of del h del y dash, this is equal to 0, where the functional is this one h x y, that is f of integration x0 to x1 f of x y y dash plus lambda g x y y dash into dx. Okay, so this is the one form of calculus of variation, one specific form you can say. Okay, so let us take an example to see how can we solve the isoperimetric problem, and this example you can take as the working procedure or working rule. Okay, so the example says that here find the extremal iy is equal to integration 1 to 4 y dash square dx, where y1 equal to 3 and y4 equal to 24, and subject to the constant 1 to 4 y dx, this is equal to 36. So here we say the auxiliary functional, or we just write the auxiliary functional is given by what the auxiliary function is given by I is equal to what, integration 1 to 4 y dash square plus lambda into y, this is of dx. Okay, so that means h is equal to what, h is equal to, or h is equal, or l is equal to, we can write y dash square plus lambda into y. Okay, now we apply the Euler-Lagrange equation for y, h. Okay, so that means el equation is del h del y minus dx of del h del y dash is equal to 0, and we solve this equation to get the solution or to get the extremal. Okay, so del h del y means here I think, yeah, right, del h del y, this means lambda minus what, dx of del h del y dash means 2y dash is equal to 0. This implies what, lambda minus 2y double dash, this is equal to 0. This implies y double dash is equal to lambda by 2. Okay, so y double dash is equal to lambda by 2. That means okay, so y dash is equal to, we can write lambda by 2 into x plus c1, and y equal to, we can write lambda by 4x square plus c1x plus c2. Okay, so this is the value of y including the constant c1 and c2. Okay, now what we can do, yeah, we apply the conditions, y1 equal to 3 and y4 equal to 24. So y1 is equal to 3 and y4, this is equal to 24. Okay, y1, yeah, so y1 equal to 3 means what, we can get 3 is equal to lambda by 4 plus c1 plus c2. Okay, that means we get c1 plus c2, this is equal to 3 minus lambda by 4, and apply this condition, we get lambda by 4 into 16, so 4 lambda plus 4x plus c2, this is equal to 24. 4 c1 plus c2, so I think this is I take 1, so that means 4 c1 plus c2, this is equal to 24 minus 4 of lambda. Now we solve these two equations for c1 and c2. Okay, so if we solve these two equations for c1 and c2, we can write, so if we subtract 2 minus 1, then we get 3 c1, this is equal to 24 minus 4 lambda minus 3 plus lambda by 4. Okay, so this is equal to 21 minus 4 lambda minus lambda by 4 minus 16 lambda minus lambda by 4. I think we can write it is right. Okay, yeah, so 21 minus 15 lambda by 4, this implies we can write c1 is equal to 7 minus 5 by 4 lambda. Okay, so we solve this c1 and we get the c1 in terms of lambda. Okay, now so c2 equal to, we can write from 1 c2 equal to, we can write 3 minus lambda by 4 minus c1, so minus 7 plus 5 by 4 lambda. Okay, so this means minus 4 and minus, I think minus 1 by 4, 5 by 4, so plus this is lambda only. Okay, so c2 equal to minus 4 plus lambda, so we get the value of c1 and c2. Now we put these two values c1 and c2 in this equation. Okay, so that means we get y equal to what, lambda by 4 x square plus c1 means 7 minus 5 by 4 lambda into x plus c2 means lambda minus 4. So this is the value of y in terms of lambda. Now we take lambda and we have to also what, lambda को यहाँ से मतलब जो है बाहर करना पड़ेगा. ठीक है, तो what should we do, we should apply this condition, this one, this constant. Okay, so integration 1 to 4 y dx, this is equal to 36. So this is the value of y. Now simply we apply what, integration y dx is equal to 36, integration 1 to 4, and we here put the value of y which is equal to in terms of lambda. So integration 1 to 4, y means the value of y is lambda by 4x square, lambda by 4x square. So this is lambda by 4x square plus what, 7 minus 5 by 4 lambda. So 7 minus 5 by 4 lambda into x plus lambda minus 4 into dx, this is equal to 36. Now we integrate this one to get the value of lambda. Okay, so this implies what, integration 1 to 4, now integrate directly. So lambda by 4 into x cube by 3, and this is the limit is 1 to 4, plus 7 minus 5 by 4 lambda, and x means x square by 2, the limit is 1 to 4, plus lambda minus 4 into x, and the limit is 1 to 4, this is equal to 36 clearly. Okay, so this is lambda by 4 into 3 we can write, and this is 4 into 3, these 3 outside the limit, and this means 64 minus 1, so 63. So 3 21s are 63. This implies we can write this is 21 lambda by 4 plus this is 7 minus 5 by 4 lambda into this is 4 minus 1, 3 by 2. So 3 by 2, I think, 16 by 2 means 8. Just a minute, 1 by 2 into 4 square means 15. Okay, this one is 15 plus lambda minus 4 into 4 minus 1 means 3. This is equal to 36. So 21 by 4 lambda plus this is 15 by 2. So 105 by 2 minus 75 by 8 lambda plus 3 lambda minus 12 minus 36. This is equal to 0 we can write. Okay, so this implies these are the lambda terms, so I think it is the LCM. So 42 lambda minus 75 lambda, and 3 8s are 24, 24 lambda plus this is 2, so 105 minus 48 96, I think, yeah, this is equal to 0. Okay, so this is equal to from this we can write here, so this is equal to 42 plus 24 is 66, I think. So minus 9 by 8 lambda plus this is 9 by 2, I think. So this is equal to 0. That means minus 1 by 8 lambda, this is equal to minus 1 by 2. That means lambda equal to simply 4. Okay, so we get the value of lambda also, lambda equal to 4. Now we put this value of lambda to this equation. So lambda x square by, I write once, so lambda by 4 y equal to lambda by 4 x square plus what, 7 minus 5 by 4 lambda into x, 7 minus 5 by 4 into lambda x plus lambda minus 4. Yeah, so this is the value, I think. Oh, sorry, yeah, we can put here, and we can put the find the values of c1 c2 also and put it here also. Okay, so lambda equal to 4, that means this is x square, and 4 means 7 minus 2 plus 2x plus this is 0. So y equal to x square plus 2x is the required extremal. Okay, so this is a standard problem of isoperimetric problem. Okay, so see first what is the steps, what are the steps we apply here. First we write the auxiliary extremal. Okay, so first we write the auxiliary extremal, then we apply the Euler-Lagrange equation and find the value of y in terms of c1 and c2, then apply the given conditions, to get the equation in terms of C1 and C2, and then in terms of lambda, okay, to get the value of C1 and C2 in terms of lambda, okay, then put those values to the given condition or given constant. Okay, so this is the given constant, integration y dx is equal to 36, okay, and then solve it to get the value of lambda, and then put the value of lambda to the equation which including the terms of lambda. Okay, so this is the complete procedure of isoperimetric problem. Okay, so in this lecture we already understand, I think we already understand the isoperimetric problem. So this is a small lecture. So I once say one thing, that the steps. So first we write the auxiliary extremal, auxiliary functional, then step 2 is what? apply Euler-Lagrange equation, okay, and then get value of y in terms of C1, C2 and lambda, okay, then apply given condition and get what? Two equations on C1 and C2, okay, and then number 4 is solve for C1 and C2, okay, in terms of, यहाँ पर लिख देते हैं, in terms of lambda, okay, then what? Put the quantity to the given constant to get lambda. Okay, so these are the steps you can say for the isoperimetric problem. Okay, so I think you all understand this lecture, this small lecture. Okay, so if you understand properly, then give a like to this video, share with your friends and subscribe this channel. Okay, thank you friends, see you again in the next video. Thank you.